Good morning. Welcome to this presentation. This presentation we have studied about the carbonyl compounds. Structure of the carbonyl compound. The carbonyl carbon atom is sp2 hybridized orbital and its three groups are attached lie in the same plane. That a trigonal planar structure, the bond angles between three attached atoms approximately 120 degree. The carbon-oxygen double bond consists of two electrons in a sigma bond and two electrons in a pi bond. See the structure. This is a planar structure. The each atom bond angle have the 120 degree. The more electronegative oxygen atom strongly attracted electrons of both sigma bond and pi bond, causing the carbonyl compounds highly polarized. The carbon atoms bears the substantial positive charge and oxygen bears a substantial negative charge. Generally, carbon have the positive charge, oxygen have negative charge in only carbonyl compound. Because of oxygen is more electronegative atom compared with carbon. Therefore, the pi electron density or pi electron clouds are moved towards the oxygen. At the same time, the carbon bear the electron deficient. What are the aldehydes? In aldehydes, the carbonyl compounds have at least one hydrogen atom bind with the carbonyl group, such as methanol, ethanol, propanol, and methylbutanol. Show the structure in the some aldehydes. What are ketones? The ketones, the carbonyl groups have attached with two hydrocarbons, such as either alkyl group or aryl group. Alkyl group means aliphatic ketones, aryl group means aromatic ketones. Some cases, one is a alkyl group, another one is aryl group, considered as aromatic ketones, such as propanone, butanone, and pentanone. The carbonyl compounds are classified into two types. One is a class 1, another one is class 2. The class 1 molecules or compounds are cannot replaced by nucleophile because of hydrogen carbonyl group bear with the hydrogen and alkyl group. The both are negative inductive effect. Because of the carbonyl group is the electron withdrawing group, the electron clouds are moved towards the carbonyl carbon. The carbon and any alkyl group or hydrogen have the positive charge. So these are thus not easily replaced by nucleophile. Otherwise, the compounds, the class 2, the compounds with groups the carbonyl group replaced by nucleophile, such as carboxylic acid, ester, acetic anhydride, acyl halide, such as hollow compounds. Next one, amides, aliphatic amide or aromatic amide. These groups are easily replaced by nucleophile because of these groups operate in the positive mesomeric effect. Generally, the carbonyl compounds as electron withdrawing group, the oxygen and nitrogen containing the lone pair of electron donate to the carbonyl carbon. So, the inductive effect dominated by the mesomeric effect. Therefore, the carboxylic acid, ester, acetic anhydride, acyl halide, and amides are easily replaced by nucleophile. Next one, the chemical properties. Generally, the carbonyl groups are more reactive because of two different atoms. One is oxygen atom, another one is carbon atom. Both are different electronegativities. Generally, the carbon pi bond, carbon oxygen pi bond is a polarized bond. It produces a partially charge of positive charge have the carbon and oxygen have the partially negative charge. Aldehydes are usually more reactive towards nucleophilic substitution reaction than the ketones because both steric and electronic effect. And second one, electronic effect. This electronic effect is due to positive charge on the carbonyl group. Greater the positive charge, then greater reactivity. In ketones, positive charge on the carbonyl group is reduced because two alkyl groups when compared with aldehyde. Already we know aldehyde groups, the carbonyl group attached with at least one hydrogen atom. But in the keto group, the carbonyl group attached with the two alkyl group. Therefore, the two alkyl groups are donate the electron and reduce the positive charge or stabilize the positive charge. Therefore, the ketone is less reactive compared with aldehyde. And third point, steric effect. The steric effect is due to number of alkyl groups or size of the alkyl groups. As the number and size of the alkyl group increases, the attack of the nucleophilic file decreases and the reactivity also decreases. Generally, the nucleophile added to the carbonyl carbon, the carbonyl group where some cases have the bulkier group or large number of alkyl group does not easily approaches to the carbonyl carbon. So therefore, the highly steric hindrance of the molecule less reactive in the carbonyl compounds of nucleophilic addition reaction. In aldehydes, only one alkyl group is present, whereas ketone have the two alkyl groups are present. Generally, the aldehydes are more reactive compared with ketone. Geometry of the nucleophilic attack on carbonyl compounds. Already we know the structure of the carbonyl compound. The carbonyl compound have the sp2 hybridized carbon atom. The sp2 hybridized carbon atom is a planar structure. The nucleophile added to the carbonyl carbon. At the same time, the pi electrons are transferred to the oxygen. The sp2 hybridized carbon converted into the sp3 hybridized carbon. The sp2 hybridized carbon atom have the planar structure of carbon atom, but the sp3 hybridized carbon considered as tetrahedral structure. See the picture. We use the example of hydration of formation gem diols illustrated nucleophilic addition reaction to the carbonyl compounds. However, other nucleophiles can undergo the same reaction. Nucleophilic addition to the carbonyl group. A key reaction mechanism of carbonyl is nucleophilic addition reaction, such as 1,2 addition. Attack of the nucleophile on the trigonal planar carbon results in the tetrahedral product. See the reaction. The carbonyl group break by the nucleophile. The nucleophile added to the carbonyl carbon. The pi electron of carbon oxygen, pi electron shift into the oxygen. Formation of carbanion. And then nucleophile abstract by the carbanion, oxygen containing anionic charges to formation of nucleophilic addition product. The next one, ketoenol tautomerism. In this ketoenol tautomerism is a stabilized structure of ketone. The ketoenol tautomerism is a chemical equilibrium between keto form and enol form. The tautomers are claimed to exist between keto and enol forms. Interconversions of two forms necessities of the migration of alpha hydrogen atom as well as recognition of bonding electrons, thus the isomerism referred to as tautomerism. See the structure. The left side present in the keto form. The keto form transferred into the enol form. The alpha hydrogen atom abstracted by the oxygen. So this alpha carbon and carbon 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 double bond. At the same time, the oxygen containing lone pair of electron accept the hydrogen to formation of enol structure. Enolate versus enol. Generally, the enolate means the enol containing hydrogen atom, hydroxy group containing hydrogen atom replaced by any one base, formation of enolate ion. The main differences between enols and enamines is that enols have hydroxy group next to the carbon-carbon double bond, whereas the enolate have negative charge of oxygen atom of the enol, and enamines have amine group next to the carbon-carbon double bond. Both the enol and enamine have the same structure, but the enolate ion, the enol containing hydrogen atom will be replaced by any one base. So therefore the enolate ion more reactive compared with enol. We are discuss about some questions about enol and enolate ion. Which is more reactive, enol or enolate? Due to their negative charges, enolate is better nucleophile, more versatile than enols. The increased reactivity of them makes them capable of wider range of reactions than enols. Also, alpha hydrogen containing compounds can be completely converted and then enolate by reaction with a strong base. A enolate is a carbon ion. Enolate is an ion derivative of ketones and aldehydes, from which they can be made by removing alpha proton from alpha carbon atom close to the carbonyl group is carbon. The next question, what is the difference between keto and enol? Keto denotes the existence of carbonyl bond in the tautomer, whereas enol denotes the presence of double bond plus a hydroxyl group. Both the keto tautomer and enol tautomer have stabilizing factors that affect the keto-enol tautomerism equilibrium. The next question, why are enols are unstable? Enols are unstable for the couple of reasons. The first reason, free electrons on the oxygen atom can act as base or nucleophile for the chemical reactions. More commonly, one must consider that any time you have an enol, it can undergo tautomerization, a conversion to what is called keto-enol tautoform. Can amides form enolates? Esters and amides also form enolates on treatment with a strong base. Because of we are used the strong base, the alpha proton is less acidic both cases than in a ketone. The another topic, the very strong nucleophile of the Kirchner reagents. Organomagnesium halides were discovered by a French scientist Victor Kirchner in 1090. Kirchner received the Nobel Prize 1912, and organomagnesium halides are now called Kirchner reagents. Kirchner reagents have great use in organic synthesis. In generally, alkyl halide react with metal, magnesium metal in presence of ether, as a dry ether, to formation of alkyl magnesium halide. Suppose we are used in the aryl halide such as benzene, chlorobenzene or bromobenzene to form in presence of magnesium to formation of aryl magnesium halide. The both the alkyl magnesium halide and the aryl magnesium halide considered as a Kirchner reagent. The order of reactivity of halides magnesium with alkyl iodide is a more reactive compared with alkyl bromide, compared with alkyl chloride. Very few reactive only for the fluorides. Restriction of the uses of Krichner reagents. The Krichner reagents is a very powerful base. It is not possible to prepare Krichner reagent from an organic group that contains an acidic hydrogen. Suppose acidic hydrogens easily replaced by base. Krichner reagents are powerful nucleophile. It is not possible to prepare Krichner reagent from any organic halide that contains carbonyl group, epoxy, nitro or cyano group. See the structure. This is one of the aldehyde group. The aldehyde group containing one aldehyde hydrogen. The next carbon containing hydrogen atom is alpha hydrogen. The alpha hydrogen is more acidic hydrogen. Okay, we will discuss the next slide. Thank you.